Okay, this section is about covalent bonds. When you have a covalent bond, it's actually a sharing of electrons. So both of the atoms think they have 8 valence electrons. And the force that holds atoms together in a covalent bond is the attraction of each atom's nucleus for the shared pair of electrons. So fluorine, for instance, has 7 valence electrons. It can bond with another fluorine, and when you put them together, then this fluorine thinks that all of these, it's filled with 8 electrons because of this pair, and then this fluorine is the same way. It's filled, has 8 electrons in its level, so even though it's a shared pair of electrons, they both are stable at 8. One thing that's important to know is that covalent bonds only happen between nonmetals and nonmetals. If I have oxygen atom here in water, when the nitrogen atom and ammonia each have 8 valence electrons as a result of forming covalent bonds with the hydrogen atom. So here's water. So we have oxygen, we know has 6 valence electrons. Hydrogen has 2, and they just kind of plug in there like a puzzle. And oxygen is satisfied at 8, and hydrogen is satisfied at 2. Remember, hydrogen only has 1 energy level, which is full at 2, so that's why it's satisfied at 2 and not 8. And if I have ammonium, it looks like this. 1 nitrogen that has 5 valence electrons, and then you can plug in each of these hydrogens into each of these open spots, and it has 3 covalent bonds. It has 3 single bonds. So it's like a single pair of shoes. You actually have 2 in there, but it's a single pair. Covalent bonds can also have double and triple bonds. So if I have 2 oxygen atoms that are bonding together, you can move those valence electrons around. This has 6, and this one has 6. And this oxygen, when I move them around and create a double bond, and a double bond is like 2 pairs of shoes, if you think of it that way. This oxygen atom here on the left feels like it's got the 2 at the top, 2 at the bottom, and then the 4 in the middle. So that's 8. And the same thing with this oxygen. 2, 2, and the 4 that it's sharing in the middle. That's a double bond. That's 1 double bond. If I have carbon dioxide, this actually has 2 double bonds. This is a double bond here between this oxygen and carbon, and this is a double bond here between this oxygen and carbon. And then if I have nitrogen, the only way to make this, both of these satisfied in a covalent bond is to have 1 triple bond. So triple, 3 pairs. And each nitrogen feels like it's full at 8, and so therefore it can bond that way. Some properties you should know at lower melting points, lower boiling points. They do not conduct electricity when melted or dissolved in water. You should also know covalent bonds only happen between a nonmetal and a nonmetal. Now there's an unequal sharing of electrons sometimes, and that is if I have this fluorine here, that's a nonpolar bond. That means it's an equal sharing. There's no lopsidedness, if you can think of it that way, when fluorine bonds with fluorine. But when I have hydrogen with fluorine, it's an unequal pull. It seems like everything is being pulled here towards the fluorine. So that would be a polar bond. Carbon dioxide lines up this way molecularly when we're looking at it. And when I have water, it actually lines up a little lopsided. So we end up having one end that's slightly positive and one end that's slightly negative. And so these end up, if you have a whole bunch of these water molecules, the negative end attaches to the positive end, and then it keeps going like a chain. So that's the end of the covalent bond section. And you're going to go to this Google form now, and remember that you must use your Pleasanton account in order to access the form.